Hello, students. Let's discuss today about the transistor and its applications. Before going to start, again, we are going to acknowledge AI, and today we are going to use another book as well for reference due to its simple and easy language. This is our agenda today. We will have an introduction to transistor, then types of transistor. In between these types, we have BJT and FET. So BJT is bipolar junction transistor, FET is field effect transistor. We will try to cover today this type, that is bipolar junction transistor, or BJT. Let's have an introduction, a quick introduction. So we are already familiar with a diode. It's also called a crystal diode. So when a third doped element is added to that crystal diode in such a way that two p-n junctions are formed, so the resultant device is called transistor. That means now there will be a third doped element added with a diode, so there will be three terminals. And it was invented by these scientists in 1948 in Bell Laboratories. And transistor has become nowadays the heart of most electronic applications. This is the very basic building block of majority of the circuits, whether they are related to some digital electronics, whether they are related to some communication, or even the computing hardware. So what is a transistor? It's a three-terminal semiconductor device that controls current between two terminals based on the current or voltage at the third terminal. And if we talk about its application, so it's used for either amplification or switching. And this is one of the most important building block, as we discussed, nowadays in the modern electronics. So almost every computer chip contains billions of transistors. So we can imagine this number. So a single chip contains billions of transistors. So now from this we can realize why they are important. So they are important due to their applications such as microprocessors, RAM, ROM, logic gates, which are studied in digital logic design, signal amplifiers, digital circuits, communication systems. So modern CPU contains billions of specifically this type of transistors, which is called MOSFET, metal oxide semiconductor field effect transistor. So if we talk about the types, we have two types. The first one is BJT, which stands for bipolar junction transistor. And why it's called bipolar? Because it uses both type of charge carriers, that is electrons and holes. While FET, field effect transistor, it uses only one type of charge carrier. So that could be any one type, either P, that means either electrons or holes. So any one type. Now, if we talk about the construction, so regarding the construction, it's just like a substrate or a wafer on which initially there is one region which is doped as either N or P. So it depends on its type. So let's say, for example, this region known as collector is doped as N type, while the mid region called base is doped as P type, and again this region called emitter is doped as again N type. So this becomes a NPN transistor. Another possibility is P and P. So these are the two possibilities for the this transistor, either NPN or PNP, and these three regions are called emitter, base, and collector. So these two types, which is either NPN or PNP, we can understand in this way that this is a PN junction in between base to collector, and again this is a PN junction in between base to emitter. Similarly, in this arrangement, there is a PN junction between base and collector. Again, there is a PN junction in between base and emitter. While mostly in between these two types, we use NPN in most of the cases. So these are the representations of these two types, NPN and PNP. If we talk about the base material, so that is very lightly doped in terms of the doping, and also in terms of the size, it's very narrow compared to emitter, which is heavily doped, and compared to collector, which is more or large in the size. So let's have a look on the doping as well as size or thickness of these regions, and there is some purpose behind that. So emitter, it's heavily doped comparatively, and base, it's very lightly doped, and collector, comparatively, it's moderately doped, means more than base, less than emitter. We can uh, see in this way: emitter doping more than collector, collector doping more than base, and each has some purpose. Similarly, in terms of size or thickness, uh, the emitter, it has medium size compared to collector, which is large, while base is very thin or smaller in size. So we can have the idea of the base that is extremely thin, which is typically in micrometers. And we know the scale of micro, 10 to the power minus 6. So we can imagine the size of these regions. Now, if we talk about the symbols, because when we will draw the circuits, so we need schematic symbols. And they are like this. We have to focus on the arrow. In NPN, the arrow is out. In PNP, the arrow is in. This is collector, base. Arrow will be always at the emitter. So if arrow at the emitter is out, that is NPN. If arrow is in at the emitter, that is PNP. So again, the term bipolar refers to the use of both charge carriers, which is electrons and holes. Now, if we talk about the working principle, that's very simple. A small current at base controls a much larger current between collector and emitter. And that's the reason the transistor either acts as a switch or as an amplifier. So usually we take the output in between these two terminals, which is collector and emitter, while we control the input from the base. So now let's have a look to different operating regions so that we can get the idea that when transistor acts as a switch or in which region, in which operating region, and in which operating region it acts as an amplifier. So different regions of operations are cutoff region, saturation, active, reverse active. Now for simplicity, these first two regions, cutoff and saturation, in these two regions, transistor acts as a switch. In cutoff, that is switch off. We will see how. In saturation, that is switch on. So in these two regions, transistor works as a switch. In active region, transistor works as an amplifier. While this reverse active region, this is very rarely used, and also this is not in the practice, so we will not focus in this region. Well, we will focus on these three regions. So let's start with the cutoff region. In cutoff region, both junctions, that is base to metal junction as well as base to collector junction, they both are reverse biased, as we can see from the polarities of these batteries. So both positive are at connected at N side. So both junctions are reverse biased. In this case, there will be no base current, ideally zero or approximately zero. We know this approximation because there is very minute current due to the minority charge carriers. Similarly, uh, no collector current, as this is switch off condition, or both junctions are reverse biased. And the result is that transistor acts as off. Further, we can say it acts like an open switch. Further, in terms of logic, we can say this is just like logic 0. Now, saturation region, in which transistor acts as on. Now, the batteries polarities are reversed and they are connected in a way that both junctions are now forward biased, as we can see from here. So the behavior is that now collector current is maximum because it's on. So in on, whatever the maximum possible current is, that will flow through the circuit. So not controlled by beta anymore. This beta is a term which is called current gain, and that's used in amplification. So that is no any use over here. Similarly, if we talk about voltage, this is just like a voltage drop in on condition, and that is approximately 0.2 volt, while it depends on a specific type of transistor as well. The result is that transistor is fully on. It acts as a closed switch, or in terms of logic, we can say this is logic 1. Similarly, in active region, transistor works as an amplifier. So for amplification, the setting is that base to emitter junction, this is base to emitter junction, or this is base to emitter junction, this should be forward biased, and base to collector junction should be reverse biased. In this way, it will work as an amplifier. That means a small base current will control a large collector current at the output. So collector current will be beta times, which is current gain, base current. So whatever will be the change in base current, that will be multiplied by this current gain, which is beta, at the output side, which is collector current. So result is that transistor works as an amplifier. It's used for analog circuits or amplification. So if we summarize, these are the four regions. So when both are forward biased, this is first quadrant, it's saturation. And if base to emitter junction is forward bias, base to collector is reverse bias, this is active or forward active. If base to emitter is reverse bias, base to collector is forward, this is reverse active, which is not used in practice. While if both are reverse biased, so that is cut off. And again, we can summarize still. So switching operation uses two regions, that is cut off, in which it acts as off or switch open. It's T over here. And similarly, in saturation, it's on or switch closed. Amplification uses active region, in which there is a controlled current flow, which is controlled with the help of the base current. Now, and there are few possible connections or configurations uh, in the transistor. The first one is common emitter. So actually these are three connections or configurations, as there are three terminals. So there are three possible configurations. The first one is common emitter. It means in this configuration, this emitter terminal is common in between input and output. Similarly, in common base, this is now the base terminal which is common in between input and output. And similarly, now common collector, so it's the collector side, and now this is common in between input and output, and each of the configuration has its specific characteristics which can be discussed later on. So let's now focus on the working of the NPN transistor, and let's try to summarize the transistor, specifically the BJT transistor, with this working. So this diagram shows that this base to emitter junction is forward biased and base to collector junction is reverse biased. And in this case, this transistor will act as an amplifier. If we apply the Kirchhoff's current law, we can see base current and collector current can be added to get the emitter current, while the collector current is beta, that is current gain, multiplied by the base current. And this equation tells us how much current will be amplified at the collector depending on the beta as well as the base current IB. If we talk about the importance of this transistor action, from this we will also realize why it's called transistor. So the input circuit, which is base to emitter or emitter to base, it is low resistance because that is forward bias. Whereas output circuit, which is collector to base junction, it is high resistance due to reverse bias. So we can say that the input emitter current almost entirely flows in the collector circuit. Therefore, a transistor transfers the input signal current from a low resistance circuit to a high resistance circuit. And that is the meaning of the word transistor. That is transistor, that is transfer and resistor. So transfer of resistance. And with this, we conclude this, that it's a semiconductor device which is used to either switch electronic signals, that means switching, or amplify the signals, that is amplification. So it has three terminals: emitter, base, collector. Function: emitter emits charge carriers, base controls the current, and collector collects charge carriers. And in this way, we conclude this topic. Further, if there are any relevant questions, so kindly note them. We will discuss in our live session. Thank you for your active participation. Take care.